We are today starting one new chapter, electrochemistry. Now, what does it deal with? It deals with the conversion of electrical energy to chemical energy and chemical energy to electrical energy and those appliances which are using this principle. We are going to study about this in electrochemistry. Now, why should we study electrochemistry? See, electrochemistry, if you study or if you know how these processes are going on, there are lot of extraction of metals which depends on this electrolytic process, that is extraction of aluminium, extraction of sodium, extraction of potassium, etc. Then preparation of chemicals like sodium hydroxide. Then we know that the different cells we are using, all are using these principles which are we are going to study. So it is better to study, it is a good thing to study electrochemistry, So now we are then coming to what are the basic principles we will have to study before we enter into this chapter. In 11th class you have studied oxidation and reduction in terms of removal of electrons and addition of electrons or transfer of electrons, we can say. Now what is oxidation in terms of electrons? In terms of electrons, oxidation is removal of electron. For example, when zinc is converted to zinc 2 plus 2 electrons. 2 electrons are removed from zinc atom, or zinc is losing 2 electrons and zinc is oxidized to zinc ions. So this is oxidation. Losing of electron is oxidation. Now then what is reduction? Reduction is gaining of electrons. Cu2 plus 2 electrons gives Cu. See here copper ions are reduced to copper by accepting 2 electrons. Copper ions accepts 2 electrons and become copper atom. So this is reduction. So oxidation and reduction in terms of transference of electrons. So zinc is oxidized to zinc ion by losing 2 electrons and the copper ions are reduced to copper by accepting 2 electrons. So this is oxidation and reduction in terms of transference of electrons. Now we come how we can use it in electrochemistry. See, last year you have studied we can do this two reactions into separate units. That is, suppose you dip a zinc rod in zinc sulfate solution. Zinc rod is dipped in zinc sulfate solution. This is zinc rod dipped in zinc sulfate solution. This is zinc sulfate solution. And copper rod is dipped in copper sulfate solution. Copper rod is dipped in copper sulfate solution. This is copper rod dipped in copper sulfate solution. So zinc rod is dipped in zinc sulfate solution and copper rod is dipped in copper sulfate solution. Now these two are connected by a voltmeter. These two rods are connected by a voltmeter and the two solutions are connected by a glass tube. We call it as salt bridge. This glass tube contains potassium chloride solution and it is closed with agar-agar, a gel of agar-agar. This is I have kept zinc in zinc sulfate and a copper in copper sulfate solution. And you have studied displacement reaction, that is zinc when it is dipped in copper sulfate solution, zinc displaces copper from copper sulfate and become zinc sulfate and copper. This we have already studied. So zinc when dipped in copper sulfate solution, you get zinc sulfate and copper, the displacement reaction. Since zinc is more reactive than copper, zinc can displace copper from copper sulfate solution to form zinc sulfate and copper. This is, see, zinc is in oxidation state 0 and here it is 2 plus. Here copper, the oxidation state is 2 plus and here it is 0. So the reaction, that is zinc is losing 2 electrons, copper ions are gaining 2 electrons. Now this is what we are doing in two separate compartments. So zinc is dipped in zinc sulfate. Now the zinc rod, there are zinc atoms, they lose 2 electrons and become zinc ions plus 2 electrons. So zinc is oxidized to zinc ion at the zinc electrode. Now what about here? At the copper electrode, what is happening? The copper ions from the solution, Cu2 plus from the solution, accepts 2 electrons to become copper. So zinc is oxidized to zinc ions, and here copper ions are reduced to copper. So the electrons, this rod will become rich in electron, then they will move through this and reach copper electrode. So this is a movement of electrons take place, and a movement of electrons we call it as electric current. And why we kept a salt bridge, and we will get a voltage of 1.1 volt. A 1.1 volt is there, will be there in the reading the voltmeter. That means electrons have the electric current of 1.1 voltage is flowing through the circuit. Now here, what is the function of the salt bridge? We have studied in 11th class the function of salt bridge. So this salt bridge keeps the electrical neutrality of the two solutions. That is, it allows the ions to move through here, because zinc ions concentration will become more, and here the negatively charged sulfate ion concentration become more. So to make them electrically balanced, this ions can move through this salt bridge, and they keep the electrical neutrality, and it keeps the solutions always connected. So otherwise it will be an open circuit. To make it a closed circuit, we will have to use this salt bridge. So this is how see here what is happening is the electrical energy is chemical energy is converted to electrical energy. That is, oxidation and reduction is taking place, and that due to that chemical reaction, electrical energy is produced. So this is one type of, this is what is the basic principle. And so in electrochemistry, we are going to study with the appliances which convert electrical energy to chemical energy, and appliances which convert chemical energy to electrical energy. So these appliances or these devices are called electrochemical cells. They are called electrochemical cells. So electrochemical cells. So the electrochemical cells are the devices which converts either chemical energy to electrical energy or electrical energy to chemical energy. Now there are two different types of electrochemical cells. One is galvanic cell. Galvanic cell, in which chemical energy is converted to electrical energy by a spontaneous chemical reaction. By a spontaneous chemical reaction, the chemical energy is converted to electrical energy in a galvanic cell. For example, this type of voltaic cell, this is a voltaic cell. In voltaic cell, the chemical energy of a reduction reaction is converted to electrical energy. So such cells are called galvanic cells. So in galvanic cells, the chemical energy is converted to electrical energy. Now whereas in second type of cells, the electrical energy is converted to chemical energy. Such type of cells are called electrolytic cells. Electrolytic cells. So galvanic cells and electrolytic cells are the two different types of electrochemical cells. In galvanic cells, chemical energy is converted to electrical energy, whereas in electrolytic cells, the electrical energy is converted to chemical energy, and a non-spontaneous chemical reaction is carried out. So in galvanic cells, spontaneous chemical reaction, we have studied spontaneity in 11th class. A spontaneous chemical reaction takes place and electrical energy is produced. Whereas in an electrolytic cell, by passage of electric current or electrical energy, what we are going to do? We are carrying out a non-spontaneous chemical reaction. So with the help of electric current, a non-spontaneous chemical reaction is carried out in electrolytic cells. So these are the two different types of electrochemical cells, the galvanic cells and electrolytic cells. First we will start with the galvanic cells. So one example is this voltaic cell, in which zinc is oxidized to zinc ions and copper ions are reduced to copper. Now, according to sign convention, the electrode at which oxidation takes place is called anode. Electrode at which oxidation takes place is called anode, and the electrode at which reduction takes place is called cathode. So, electrode at which oxidation takes place is anode, and electrode at which reduction takes place is cathode. Always in both these two types of cells, always oxidation at anode and reduction at cathode. There is no change for that. So here zinc is the anode because oxidation is taking place for zinc, and copper is the cathode because reduction is taking place at a cathode. Understood? So zinc is the anode and copper is the cathode. Now, how to represent this galvanic cell or voltaic cell? When we represent a cell, first you will have to write the electrode. First you will write the half cell where the oxidation takes place. This setup, that is a metal with a salt solution, is called a half cell. A metal with a salt solution. Here zinc is dipped in zinc sulfate, it is a half cell. Copper is dipped in copper sulfate, it is another half cell. Now here the oxidation is taking place in this cell, that is the zinc to zinc sulfate, that it is called oxidation half cell, and wherever reduction is taking place it is called reduction half cell. So a cell consists of two parts, two half cells. One in which oxidation is taking place and that it is called the oxidation half cell, and one in which reduction takes place, it is called the reduction half cell. So whenever you are representing a cell, you will have to represent the oxidation half cell first and then the reduction half cell. When you are representing an oxidation half cell, first you represent the electrode. Which is the electrode here? Zinc. Zinc is the electrode. Zinc solid is the electrode. Then what is the ion? Salt solution with which it is in contact? It is zinc 2 plus ion. Zinc sulfate solution. It is aqueous. You will have to write the concentration then. Concentration of the solution in molarity. So this much molar solution you will have to write. Then the salt bridge. A salt bridge is represented by two parallel lines. Then we will write the reduction half cell. When you are writing the reduction half cell, first write the electrolyte. Which is the electrolyte here? Cu2 plus solution. Cu2 plus aqueous. And there also you will have to write the concentration. Then you will have to use the electrode. What is the electrode here? Cu salt. So this is how we represent a cell. First you write the oxidation half cell, then the reduction half cell. When you are writing the oxidation half cell, first write the electrode, then the electrolyte. And when you are writing the reduction half cell, first write the electrolyte with the concentration and then the electrode. Okay. So this is how it is represented. And in between these two half cells, there must be a salt bridge. So this is the voltaic cell and its representation. So electrochemistry deals with those devices or those changes which takes place either by the passages of current or by chemical reaction, how the electric current is produced. One is a spontaneous reaction and other is a non-spontaneous reaction. So the devices which are converting the electrical energy to chemical energy and vice versa, that is chemical energy to electrical energy, they are called electrochemical cells. And there are two different types of electrochemical cells. The galvanic cells, in which electrical energy is converted to chemical energy, and electrolytic cells where electrical energy is converted to chemical energy. In galvanic cells, chemical energy is converted to electrical energy, and in electrolytic cells, the electrical energy is converted to chemical energy. And we have now seen the voltaic cell, in which zinc is dipped in zinc sulfate and copper is dipped in copper sulfate, and these two electrolytes are connected by a salt bridge and the two electrodes are connected by a voltmeter. You can see 1.1 volt. So here what is happening is at the zinc electrode, zinc is oxidized to zinc ion and at the copper electrode, copper ions are reduced to copper. So since zinc is oxidized, that electrode is called anode, because by IUPAC convention, the electrode at which oxidation is taking place is called the anode, and electrode at which reduction is taking place is called the cathode. So zinc is the anode and copper is the cathode. Now how you represent this cell? When you represent the cell, first write the electrode, then the electrolyte. That is, you write the first oxidation half cell, then you write the electrode first, then the electrolyte, then salt bridge, then the reduction half cell. First you write the electrolyte with the concentration, then electrode. That is how usually a cell is represented. So this is a galvanic cell. Now this is the reaction taking place. The overall reaction is this one actually. Zinc plus Cu2 plus gives zinc 2 plus 2 Cu. This is the reaction that is taking place, isn't it? So when the current is, suppose I am connecting an external circuit to this cell. An external circuit or an external device is connected which is supplying electric current to this, and slowly you start with some 0.5 volt, then increase the voltage 0.5, 0.6, 0.7, 0.8 like that, and see what electric current chemical reaction is taking place. We can see that the same chemical reaction takes place till the voltage is 1.1 volt. We external circuit connect here. The external circuit means another device which is giving electrical energy to this reaction. This cell connect here. The current is flowing inside. But till the voltage becomes 1.1, till the voltage of the external circuit is 1.1. We 0.5 0.5 pass, 0.5 volt pass here, then 0.6 volt here, then 0.7 pass here. Pass here. We can see that till 1.1 volt, the same chemical reaction takes place. Zinc plus Cu2 plus will give zinc 2 plus Cu. That is the chemical reaction. Then what happens at 1.1 volt? At 1.1 volt, no reaction will take place. The reaction will stop. Suppose you increase the voltage beyond 1.1 volt, the opposite change will take place. That is, zinc 2 plus, from this will go to zinc, where here copper from the electrode will go into the full solution as copper ions. The opposite change will take place. Understood? That is, the non-spontaneous change will take. If you are giving a voltage higher than 1.1 volt. If you are connecting an external supply of current, or an external supply of current is given to this reaction, to this cell, then what happens? Till 1.1 volt, the same reaction will take place. Then at 1.1 volt, no reaction will take place. Then beyond that, what will happen? If you give a voltage higher than 1.1 volt, the opposite reaction will take place. That is, zinc 2 plus Cu will give you Cu2 plus zinc. That is, at the zinc electrode, zinc ions from the solution will accept 2 electrons and will go to zinc and deposit there, and here copper from the electrode will go into solution as copper ions. The opposite change will take place. Understood? That is a non-spontaneous change. Actually, this is a spontaneous change. The non-spontaneous change will take place. So this is the basic of electrochemical cells. That is one type of electrochemical cell, galvanic cell. Now we will go beyond that. The cell potential. The cell potential of this cell, E cell, is equal to E cathode minus E anode. E cathode minus E anode. Now what is this? Is also what we have studied in 11th class. Now what is this E cathode? It is the electrode potential of the cathode minus E anode, electrode potential of the anode. Electrode potential of cathode minus electrode potential of anode, or it is also E right minus E left. E right minus E left. E right, at the right side you have copper sulfate. So that is E right, or electrode potential of the electrode where reduction is taking place, minus E left, that is electrode potential of the electrode at which oxidation is taking place, that is E left. So E cell is equal to EMF of the cell. The difference in the electrode potential we can write it as the EMF of the cell, and EMF of the cell is E right minus E left, or E cathode minus E anode. Then the question you can ask is how electrode potential, what is electrode potential, how is it developed, that we will study in the next class.